Hi everyone, welcome to the recap video for week 11 of Stats 220 Online. This week we're going to review the module on two sample problems. So I thought I'd start off with a problem to illustrate what the issues are in this week's modules. So researchers are investigating a new drug hypothesized to change systolic blood pressure. A random sample of subjects is selected. Each subject had their systolic blood pressure measured before taking a drug and then after taking a drug. So they have two measurements. Each subject has two measurements. A baseline, which is before the drug was taken, and a post-treatment after the drug was taken. And you'll see here, you're given the data, and you're given the 5-number summary for the baseline values, for the post-treatment values, and for the difference between the baseline and the post-treatment for each subject. We're also given various output for this data, along with some plots, and then we're asked to answer some questions. So let's have a look at the questions. It says the researchers are investigating whether there's a significant change in systolic blood pressure following treatment. For all questions below, use the 5% significance level. So it says, state the null and alternative hypotheses. So what are these? Well, let's go back to the data. Each subject has two measurements. So that means that we have paired data. So this is paired. It's a paired sample. So in a matched pair situation, what we're interested in is the testing whether or not the difference is zero. So in other words, is the mean of the difference equal to zero? If it is equal to zero, then there is no difference between systolic blood pressure at baseline and systolic blood pressure after treatment. But if it's different than zero, then there is some kind of change. So now we can express that in our null and alternative hypotheses. So H naught is that mu d is equal to 0 versus the alternative that mu d is different than 0. Now, which test is most appropriate in this situation and why? Well, what tests are we given? Well, we're given the sign test over here. So this is the sign test for matched pairs. We're given the t-test for matched pairs. And we're also given the two-sample t-test So the question is asking you, which one of these three tests is most appropriate? Well, it can't be this one, because we don't have two samples in this situation. If we had two samples, then the null hypothesis would be something along the lines of H naught mu1 is equal to mu2 versus, let's say, an alternative where mu1 was different from mu2. But again, that's not the case. So it's really the sign test, either the sign test or the match pairs t-test. So which is it? Well, let's have a look at the output. We're given a normal quantile plot for the differences and a box plot for the differences. Let's have a look at the box plot for the differences. Does this box plot look symmetric? No. The box plot looks right skewed. In other words, the distribution of the differences looks slightly right skewed. Also, we can see that the points on the quantile plot for the differences falls off the line, especially around these points here. So these two plots together indicate that the data are not normal. And for small samples, this means that the nearly normal condition for the t-test is not met. So back to here, so that means that we should use the sign test, because the sign test doesn't rely on the normality assumption. So the appropriate p-value here would be 0.1797. Now notice that the p-value for the one sample t-test, for the matched pairs t-test, is 0.03, and it is significant at the 5% level. So which test is most appropriate in this situation, and why? Well, it's the sign test. Since the distribution of differences is not normal. What is the p-value of this test that you chose in B? Well, the p-value, again, is 0.1797. So the p-value is 0.1797. And we would not ask you to calculate a p-value for the sign test. You would always get it off of the output. So what do you conclude based on the p-value? Well, at the 5% level, we can't reject the null hypothesis. So therefore, there's no evidence that there is a change in blood pressure. So there's no evidence at the 5% level of a change in systolic blood pressure. So that's it for this week in Stats 220 Online, and I'll see you next week.